Okay, so let's now tackle our physics reviewer. And the first part is the basic mathematical techniques and formula manipulation. So the first topic is literal equation in physics, and this is the most or the basic requirement for us to understand physics because formulas we're gonna tell a lot. Now, I would encourage you to visit here the Google Sheet for the other topics, which is the first, we have the literal equations as our first topic. We already posted the lecture video and then the link and then the sample questions as well as the link for that video as well as the annotated worksheets. So other topics for this physics, we're going to include direct variations, scalar quantities, motion in straight line, and motion in two dimensions. So let's now look at our first example. The equation F is equals to ma, relationship of force, mass, and acceleration. Express A in terms of force and mass. So from here, we have force is equals to mass times acceleration, and we're looking for the acceleration. We need to isolate the A. And so what we're going to do here is divide both sides by mass. And so acceleration now is equals to force over mass. Okay? Next. Actually, this is your basic algebra. Now, how about example number 2? We have your VF is equals to VI plus GT, derived for the value of the T or the time. And so we have here the VF is equals to VI plus GT, and we're going to look for the value of T. Now, take note, we have to subtract both sides or add negative VI on both sides. But in our case, can I just use transpose? Although there's no word in mathematics such as transpose, okay? There's no transpose in math, but we just use it for easier visualization. And so VF, then when we transfer VI on the other side, that would be VF minus VI. Okay? So it's gonna change sign. And so we're gonna look now for the value of T. You need to divide both sides by G. And so time now, or T, that would be VF minus the VI over G. Okay? Now, how about on example number 3? The formula for kinetic energy is 1/2 mv squared. What is the formula for velocity or Ke? So Ke or the V mv squared, we're looking for the V. Ke is kinetic energy. And then you multiply both sides by 2 for this part, right? Of course, it will gonna be canceled here. So this one is gonna be 2 Ke is equals to mv squared. And then we need to look now for the value of the V. And so we divide both sides first by mass. Cancel out the mass, and that would be V squared is equals to 2 Ke over M. Now, in order for us to get for the V, we get the square root of both sides. And so that would be 2 times the kinetic energy over the mass. Okay? Now, how about our example number 4? This one's a definition of impulse, which is a change in momentum per time. But we will just want to represent the mass in terms of IV and U. Now, from here, we have E, I is equals to F, MV minus MU over T. Now, we need to factor out the M. And so that would be M multiplied to V minus U. And then we multiply both sides by T, right? So that would gonna be, we multiply both sides by T. Right, so that would be I times T. Okay, the T here will be cancelled. And so after that, we need to divide both sides by V minus U. We need to divide both sides by v minus u. And this now will become m is equals to it over v minus. Okay? Now, how about our example number 5? The mirror equation is represented by 1 over f is equals to 1 over u plus 1 over v. Okay? Don't mind yet the terms u and v. Okay? We'll just need to show the correct formula for u. And so if we're going to have here the 1 over f is equals to 1 over u plus 1 over v, we need to multiply everything or both of the equation by f, u, and v. And so multiplying this, if you can see, we have f u v over f. So the f now will be cancelled. And so we also have uh, f u v over u. And look here, the u will be cancelled. Plus, so we have here f u v over v, and so the v will be cancelled. And so what is left here, we have the uv is equals to fv plus fv. Okay? Now, what we're looking here. Now, by the way, I just want to remind that you can only do this in equations, but not in expressions. Again, you can only do these in equations, but not in expression when you multiply it on both sides. Okay? So again, equations only, but not in expression. So here, uv is equals to fv plus fv. Now, since we're looking for u here, we need to group the uh, variables with u. And so here, we could factor out the u, which is v minus f is equals to vf. And so further solving, we're going to have divide both sides by v minus f, right? Cancel out the v minus f. So we have u is equals to fv over v minus. Okay? Now, how about our example number 6? The simple harmonic motion formula for displacement as a function of type is this. So we need to look for the value of the omega, right? Now, since x is equals to a multiplied to cosine, multiplied to omega, multiplied to... And so what we're going to do here is to divide both sides by a, right? And so the a here will be cancelled. And so we are left now with x over a is equals to cosine and then omega t. And then for us to remove the cosine part on that, so we need to get the inverse of the cosine on both sides, but let's just have it like this. Cosine raised to -1, or the arc cos is equals to omega. And so we're going to solve now for the time. For the t, we need to divide both sides by omega. Sorry. We're looking for omega. Sorry for that. So since we're looking for omega, we need to divide by, we can cancel out the t. And so we have now omega is equals to arc cos of x over a over all over t. And so I would encourage you to click on the other link of the video. We have here the practice set. So we have the practice set 1, number 2, number 3, number 4, and number 5. Okay? So click on the next video for the answers of this. Thank you.